On a limestone ridge in southern China, a fleet of machines is doing something construction crews once thought impossible. There is no road leading up this mountain, no way to assemble a crane, and the forest below is legally protected. Cutting a path through that forest would tear apart land that is biologically irreplaceable and protected by law. Yet, in just 3 days, more than 180 tons of steel and concrete reached the summit anyway. Nothing drove it there. Nothing was carried on human shoulders. 16 heavy lift drones flew the materials straight up. Online clips made it look almost unbelievable, as though China had built drones strong enough to snatch entire cranes. That image spread fast because it is dramatic, though it is also not entirely true to what is happening. What is actually happening is stranger, and in some ways far more disruptive than the viral myth suggested online. A complete tower crane, including its mast, counterweights, and base system, is far too heavy for any drone today. No machine is hoisting a whole crane into the air. Instead, China breaks the crane's job into smaller flights. That distinction matters more than it sounds, because for most difficult projects, the hardest part was reaching the site. A mountain tower needs a path wide enough for trucks. A remote power line needs crews willing to climb dangerously. A protected forest forces engineers to choose between slow, careful access or environmental damage they can never undo later. Heavy lift drones attack that access problem before it ever becomes a road, a cableway, or weeks of clearing. Once materials can simply fly to the build point, a surprising amount of traditional construction starts to disappear entirely. These are not oversized hobby drones, bought off a shelf. The machines on Chinese job sites carry genuine industrial loads. The Skytech S400 Plus, designed specifically for power grid construction, uses 12 propellers across 6 axes to carry cargo. The United Aircraft TD-550D is a coaxial unmanned helicopter capable of meaningful lift, even where thin mountain air weakens others. Then there is DJI's Flycart 100, a cargo drone with a winch system that lowers material with controlled precision. That winch detail is easy to overlook, but it changes everything about how these machines must actually operate. Construction drones must carry a load to an exact position, hold steady in open air, and release it safely. At that point, the drone stops behaving like a delivery vehicle and starts behaving like a small aerial crane. Once a fleet can repeat that motion reliably all day long, the mountain stops being a barrier entirely. The clearest proof of this came in Yunnan, where crews needed to build high-voltage towers in Zikou County. Limestone peaks and protected rainforest made conventional construction painfully slow, costly, and genuinely difficult to manage safely. The site also sat inside an elephant migration corridor, meaning a new access road would create an entirely new problem. A traditional approach could easily have meant weeks of ground preparation and heavy disturbance to the surrounding wildlife habitat. China sent drones instead. 16 heavy-lift aircraft flew repeated routes, carrying steel, concrete, and rigging material upward. Over 3 days, the fleet moved roughly 180 tons of material with tight positional control overhead. The forest was never opened up for trucks. No heavy cableway had to be built before the work began. The site received everything it needed from the air, while the ground below stayed largely untouched throughout the project. That is why the story matters beyond a single viral clip. It showed a power grid rising without scars. The footage feels strange because the eye expects a mountain project to look prepared with roads and fuel trucks visible. In Yunnan, materials simply appeared from above as the drones turned the open sky into a working supply route. This technology changes where engineers can choose to work without forcing the surrounding landscape to become a highway first. If this becomes the normal way of working, remote construction stops fighting terrain and becomes a scheduling problem instead. A year later, a second case in Xinjiang showed why utility companies would value this, even without new construction. A crew needed to service a transmission tower standing across a rough river and a dangerously unstable mountain slope. Under the old method, workers carried tools and rigging equipment by hand, with the one-way trip taking hours. A Flycart 100 completed the same tool transfer in 2 flights, finishing the entire delivery in under 30 minutes. The time saved was significant, but the safety change mattered even more for the workers involved in this project. The drone removed exactly the part of the job where someone was most likely to get seriously hurt. Then came a very different power grid problem in Hubei, where winter ice built up on transmission lines. Ice on power lines is never just an inconvenience. The extra weight can damage equipment and threaten the system. Clearing ice usually means putting crews near frozen steel and live high-voltage systems in brutal winter weather. China used drones to keep people away from that danger point entirely during the harsh winter freeze season. One drone carried controlled heat to melt the ice directly. Another used a suspended beam to strike ice loose. It looked unusual on camera, but the underlying logic was simple. Put the machine where the danger lives instead. Across all three projects, the same pattern keeps repeating. The drone removes only the single worst part of the job. In Yunnan, it protected the forest. In Xinjiang, it eliminated the dangerous carry. In Hubei, it kept crews away. That pattern is exactly why China's progress is hard to dismiss as merely a flashy technology demonstration online. These drones are already being built into the boring, expensive, dangerous corners of infrastructure work across the country. That is precisely where America's problem begins, since its own systems have not reached the same scale yet. The uncomfortable truth is that the United States was not actually late to heavy lift autonomy at all. It had a serious machine years before China's construction drones ever became famous online for their dramatic footage. The common K-MAX, a heavy lift helicopter with intermeshing rotors, was converted into an unmanned aircraft for combat use. It was deployed by the U.S. Marine Corps in Afghanistan, carrying supplies to outposts across terrain too risky for roads. The capability existed, and the combat testing was real, but the problem came afterward when scaling it failed. The K-MAX never became a broad civilian construction tool. It was expensive to maintain and difficult to scale. It stayed tied almost entirely to military or niche industrial use, and production eventually ended after only a small number. America had built a remarkable machine, but it never became part of everyday infrastructure work across the country. China took a different route entirely, pushing smaller heavy-lift drones into repeated, everyday civil work across the grid. One country built a remarkable machine. The other built an entire market around the mission that machine was meant for. Regulation widened that gap even further, since heavy drones quickly run into complicated approval pathways in the United States. Larger platforms do not fit cleanly into standard commercial drone rules, and approvals can take a very long time. Every added delay makes it harder for companies to build operational experience, justify investment, and prove genuine market demand. In China, drone airspace has instead been treated as a new layer of infrastructure planned alongside everything else. Licensing, flight corridors, city planning, and industrial projects are being shaped together, rather than waiting on one pilot program. Shenzhen has already pushed drone logistics corridors into regular daily use across its busy urban airspace network system. Other Chinese cities are actively planning physical space for drones the same way older cities once planned for roads. The message to industry is direct. Build the machines because the surrounding system is already being prepared to receive them. In the West, a company can have impressive technology and still face a long search for approvals and compatible sites. The machine itself turns out to be only part of the race. The airspace around it may be harder. This is also why the tower crane image, even though it exaggerates the truth, keeps sticking in people's minds. China is not lifting whole cranes like toys. It is making crane-dependent work less dependent on cranes themselves. A site that once needed a road, a staging area, and a full lifting setup can now receive loads directly. This does not replace a major crane working on a skyscraper, but it can transform remote towers and isolated lines. It can transform emergency repairs and mountain construction in ways that used to be far too costly to attempt. The first industries reshaped by these drones may not be the flashy ones at all, but the hardest to reach. There is also a military shadow hanging over all of this, since the same drones could carry far different cargo. A drone capable of carrying construction material into remote mountains is just as capable of carrying supplies into contested regions. The same route planning that moves grid components today could just as easily move equipment for security forces tomorrow. Larger Chinese drones with modular payload bays make that dual-use concern difficult for anyone to simply wave away. Western governments are well aware of the risk, which is part of why Chinese drone platforms face growing scrutiny. If America restricts the most affordable Chinese systems, while its own alternatives stay limited, industry faces a gap policy cannot fill. China's drone construction push is still genuinely early. Batteries remain a real limit on how far machines can travel. Heavy wind can turn a careful lift into a hazard in seconds, even for the most advanced industrial drones available. High altitude reduces how much weight a drone can carry, and power lines create interference risks for nearby aircraft. A drone carrying 100 kilograms is not remotely the same thing as a crane lifting a full structural module. But the direction of travel is unmistakable. These machines do not need to replace every crane on Earth to matter. They only need to remove the road, the dangerous climb, the cableway, or the extra week of ground preparation. Once that happens at scale, the underlying cost of building in difficult places starts to change for good. The next construction revolution probably will not look like swarms of drones carrying skyscrapers through the open clouds. It will likely look far quieter and more useful than that. A drone bringing steel to a mountain tower. A drone lowering tools across a river cruise could never safely cross on foot. A drone clearing ice from a line. A drone turning a remote, unreachable site into an ordinary one, without a single road cut through the land. China is already learning how to make all of that routine, while America is still trying to decide how much should be allowed. So when people say China's drones are lifting tower cranes like toy helicopters, the literal claim is simply wrong. The warning underneath that claim is not China, is proving that construction does not always have to begin on the ground. If America cannot build the rules, the markets, and the industrial pipeline fast enough to match this shift, it risks falling behind. The next generation of infrastructure may rise into the air while the West is still waiting for clearance to begin. Subscribe if you want more videos that break down the real systems behind clips exactly like this one.